Hello all. In this video we will discuss some solutions based on topic force, terminal velocity and momentum. In this question the diagram shows the forces acting on a lorry as it travels along a flat road. Two of the forces have effects that cancel each other out. Which two? Explain your answer. So there are two forces, weight of the lorry which is acting downward 5000 Newton and a contact force which arises due to the contact of lorry and contact between lorry and the road. So this is a contact force which is acting upward and the magnitude is 5000 Newton given here. So these two forces cancel out each other. What is the resultant force acting on the lorry? Give its magnitude and direction. So resultant force will be like in vertical direction these two forces cancel out each other. In horizontal direction there are two forces, 1300 Newton which is acting in the direction of the movement of lorry. It is moving toward left, and there is a drag force which is 1200 Newton. So resultant force is 1300 Newton minus 1200 Newton which is 100 Newton. Since net vertical force is 0, so net horizontal force is 100 Newton which is acting toward left side, and left is the direction of motion of the lorry. What effects will this resultant force have on the speed at which the lorry is traveling? Net force is directing toward left in the direction of motion, so the lorry will accelerate, speed up. This figure shows an aeroplane of mass is given, accelerating uniformly from rest along runway. After 26 seconds, it reaches a speed of 65 meter per second. Calculate the acceleration of the aeroplane. So acceleration is change in speed. Change in speed is 65 meter per second because it from rest it is started. So change in speed is 65. Time taken is 26 seconds. Acceleration is change in speed divided by time. It is 65 divided by 26. 2.5 meter per second is square. The resultant force on the aeroplane, force is equal to mass into acceleration. Mass is given, acceleration we calculated in part A. So it is F is equal to ma, 8.5 into 10 to the power 5 Newton. Just after taking off, the aeroplane continues to accelerate as it gains height. State two forms of energy that increases during this time: kinetic energy and gravitational potential energy. State one form of energy that decreases during this time: chemical energy. State why the total energy of the aeroplane decreases during this time. While flying, some energy is lost through drag, air friction, to thermal energy and sound energy. Some is also lost as the plane makes the air around it move. When the aeroplane reaches its maximum height, it starts to follow a curved path at a constant speed. State the direction of the resultant force on the aeroplane: toward the center of the curved path. Resultant force on the aeroplanes. This force will be of centripetal force, of circular motion. This is an example of circular motion. A large plastic ball is dropped from the top of a tall building. This figure shows the speed time graph for the falling ball until it hits the ground. Explain in terms of the forces acting on the ball why the acceleration of the ball decreases. So the weight of the ball is acting downward and the air friction drag forces opposes its motion. That increases with time. The drag forces increases with time. As a result, the reduced net downward force results in reduced acceleration. So there will be a net downward force. Drag is acting upward and the weight is acting downward. So the resultant force will be reduced and this will lead to a reduced acceleration. The ball reaches terminal velocity. Eventually, the force due to weight and drag forces are equal, opposite and balanced. Therefore, there is no resultant force. So, there is no acceleration and the ball reaches terminal velocity. I suggest you to please watch a detailed video on this topic, how the terminal velocity of body acquired and what is drag force, and for all other information. From the graph, estimate the time during which the ball is traveling with terminal velocity. So, time with terminal velocity, so 4.226, it is 1 point, total time is 1.8 second, but the time starts from 4.2 to 6 second, the time during which the ball is accelerating. This part shows the ball is accelerating. So this is from 0 to 4.2, the distance fallen while the ball is traveling with terminal velocity. So the time taken is 6 minus 4.2, which is 1.8 second, and its speed is 20 meter per second. The terminal velocity is 20 meter per second. So the distance will be speed multiplied by time. It is 36 meter. The height of the building. You have to calculate the total distance traveled. So it is, you can see that this 36 meter is the distance fallen while the ball is traveling with terminal velocity, and when the ball was speeding up, the ball was accelerating. At that time the distance, you can calculate with the formula distance is equal to speed multiplied by time. Here we have to calculate the average speed. So average speed will be 20 plus 0 divided by 2. So it is 10, and that is speed 10 multiplied by the time. Time is 0 to 4.2. It is 4.2 seconds. So 4.2 multiplied by 10 plus 36. It is equal to 42 plus 36. Nearly a value comes out to be 78 meter. In this figure shows the speed time graph for a bus during test. At time t is equal to 0, the driver starts to brake. This is test 1, PQ and QR. This another black line represent test 2. So for test 1, all information you have to give for test 1. Determine how long the bus takes to stop. It's 7 seconds. It is given at it takes 7 seconds to stop. State which part of the graph shows the greatest deceleration. PQ. PQ is showing because the steeper the slope, the greater the deceleration. Use the graph to determine how far the bus travels in the first 2 seconds. So in first 2 seconds, the average speed during first 2 seconds is 15 plus the Q value is here 5, 6, 7. This red line is shifted, but this is not here. It is at Q value. This is 7, 5, 6, 7. So the average speed is 15 plus 7 divided by 2. It is 11 meter per second. And distance you can calculate from the formula speed multiplied by time. Speed is 11 meter per second. Time is for 2 seconds we have to calculate. 11 multiplied by 2 is 22 meter. For test 2, a device was fitted to the bus. The device changed the deceleration. For test 2, a device was fitted to the bus. The device changed the deceleration. State 2 ways in which the deceleration during test 2 is different from that during test 1. So deceleration is uniform during the whole journey. In test 2 it is uniform. Why it is not uniform for test 1? For 2, average deceleration in test 2 is lower as compared to that of in test 1, as during test 2 bus takes more time to come in rest. Calculate the value of the deceleration in test 2. It is again change in speed, change in time divided by change in time. So change in speed is 15, change in time 8. Change in speed is 15 minus 0, which is 15. Change in time is 0 minus 8, which is 8 for the test 2. So it is 1.9 meter per second square. This figure shows a sketch graph of the magnitude of the acceleration for the bus when is traveling around a circular track at constant speed. The speed is constant and the bus is traveling around a circular track. Magnitude of acceleration is constant, the magnitude is constant with time. Use the graph to show that there is a force of constant magnitude acting on the bus. Since graph shows the acceleration with constant magnitude, so the force will be of constant magnitude. You know, for the relationship between force and acceleration is mass of an object is a quantity which is always constant, and acceleration is always is constant. It is given here. So force will be of constant magnitude. State the direction of this force. Force will be directed toward the center of the circular track. This is an example of centripetal force. This is a motion of circular motion. Example of circular motion. The force is directed toward the center of the circular track. Centripetal force. A solid plastic sphere falls toward the earth. This graph is a speed time graph of the fall up to the point where the sphere hits the Earth's surface. Describe in detail the motion of the sphere shown by the graph. Initially, there is no air resistance, drag force, and the only force acting on a sphere is weight. As it falls, it accelerates, which increases its speed between PQ. As a result, air resistance means drag force increases with increasing speed. This causes the resultant force downward to decrease, therefore the acceleration decreases, so it is not speeding up as quickly. Between QR we can see. It continues until the net force of the sphere becomes zero, implying that it will no longer accelerate between RT. At this stage, drag force and force due to weight are equal. This state is that it has reached terminal velocity. It would continue with this speed until it touches the ground. Use the graph to calculate the approximate distance that the sphere falls between R and T. Between R and T, you have to calculate the area under the graph. The area under a speed time graph represents the distance traveled by the object. So area between R and T is equal to distance. It is 100 minus 60 multiplied by 120. So it is 4800 meters. Distance between PQ. PQ is definitely a triangular shape here. So 1 by 2 base multiplied by height. Base is 0 to 5, 50. Base is 6. At Q it is 6. Yeah, 2, 4 and 6, it represents 6. The coordinate of Q on time axis is 6. Similarly, the coordinate of Q on speed axis is 50. So 1 by 2 multiplied by base multiplied by height gives the area of triangle. It is 150 meter in this case. On this figure, draw arrow to show the direction of the force acting on the sphere when it is at the point shown by the point S on the graph. Label your arrows with the name of the force. So on S of the graph, it reaches the terminal velocity. So the drag force will be equal to the weight of the sphere. Drag force will act in the opposite to the direction of motion of a sphere, and the sphere is falling down. So this is the weight, that direction of weight acting here. Explain why the sphere is moving with constant speed at S. Since resultant force is 0 at S, or we can say that 0 acceleration at S, so the speed is constant. This figure is a head-on view of an airliner flying at constant speed in a circular horizontal path. The center of the circle is to the left of the diagram. On this figure, draw the resultant force acting on the airliner. Explain your answer. The airliner is flying at a constant speed in a circular path, so it follows a circular motion where the resultant force is the centripetal force that directs always toward the center of the circle. Since it is given that center of the circle is toward the left of the diagram, so we have plotted the net resultant force toward the left. This is the resultant force. The weight of the airliner is given, and there is an aerodynamic lift force of 1.39 into 10 to the power 6 Newton acting at 30 degree to the left of the vertical. So this is a vertical force. Aerodynamic force is acting at 30 degree, and these are the vertical and horizontal component of aerodynamic force, Fa cos 30 and Fa sin 30. By drawing a scale vector diagram or otherwise, show that resultant of these two forces is in the same direction as the resultant force. We draw in part A. So the net horizontal force is Fa sin 30 only. So Fa sin 30, F 1.39 into 10 to the power 6 Newton, sin 30. Fx is the horizontal component. So this is equal to 6.95 into 10 to the power 5 Newton to the left. That direction is toward the left. Net horizontal component is Fa cos 30 minus the weight of the airliner, which is 1.20 into 10 to the power 8. 10 to the power 6 Newton. So this is 1.39 Fa. The magnitude of force is this much. Fa cos 30 minus the weight. So this is equal to 0. So vertical component is 0. Therefore, the resultant force has only horizontal component which is directed toward left, and it is the same direction as we draw force in part A. The speed is constant as the airliner flies in the circular path. State and explain what is happening to the velocity. Velocity is a vector quantity. It has magnitude and direction both. Now it is given that the airliner is moving with constant speed at circular path. In circular motion, the magnitude of velocity remains constant, but its direction changes at every point. So there is a change in the velocity, change in the direction of velocity, but magnitude is constant. In this question, this figure shows a dummy of mass 70 kg used in a crash test to investigate the safety of a new car. The car approaches a solid barrier at 20 meters per second. It crashes into a barrier and stops suddenly. Calculate the momentum of the dummy immediately before the crash. So momentum is mass multiplied by velocity. Immediately before the crash, the velocity was 20, mass is 70, which is given. So it is 1400 kg meter per second. Determine the impulse that must be applied to the dummy to bring it to rest. Initial momentum is 1400. Final momentum is 0 because it stops suddenly. So impulse is change in momentum, which is 1400 Newton second. In the crash test, the passenger's compartment comes to rest in 0.20 second. Calculate the deceleration of the passenger compartment. Initial velocity u was 20, final is 0. So acceleration is v minus u by t, which is minus 100 meter per second square. The seat belt and airbag bring the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80 meters per second square. Calculate the average resultant force applied to the dummy of mass 70 kg. We know force is equal to mass multiply acceleration. Mass is 70 kg and acceleration is, we have given, it is 80 meters per second square. So it is 5600 Newton. In this question, this figure shows a hammer being used to drive a nail into a piece of wood. Hammer, this is a nail, this is a piece of wood. The mass of the hammerhead is 0.15 kilogram. The speed of the hammerhead when it hits the nail is 8 meters per second. The time for which the hammerhead is in contact with the nail is 0.0015 second. The hammerhead stops after hitting the nail. Calculate the change in momentum of the hammerhead. So change in momentum is final momentum minus initial momentum. Final momentum is mass multiplied by final velocity. Initial momentum mass multiplied by initial velocity. So final velocity was 0 because it stops, and initial velocity was 8 meter per second. Mass is given, which is 0.15. Mass of hammerhead is 0.15. So it is mv minus u. Mass is 0.15. Change in velocity 0 minus 8, which is minus 1.2 kilogram meter per second. State the impulse given to the nail. Impulse is equal to change in momentum. It is 1.2 Newton second. Impulse is force multiplied by time. So the unit will be Newton force and second for time. Again, I suggest to please watch another video where we have discussed detail impulse and relationship of impulse with change in momentum. Calculate the average force between the hammer and the nail. So again, force impulse is force multiplied by time, which is equal to change in momentum. So force will be change in momentum divided by time. Change in momentum is 1.2, time is 0.0015. This is the time for which the hammerhead is in contact with the nail. So it is 800 Newton here. The engine of an unpowered toy train is rolling at a constant speed on a level track as shown here. The engine collides with a stationary toy truck and joins with it. Before the collision, the toy engine is traveling at 0.32 meter per second. The mass of the engine is 0.50 kilogram. Calculate the momentum of the toy engine before the collision. So momentum is mass multiplied by velocity. It is 0.50 multiplied by 0.32. So it is 0.16 kilogram meter per second. The mass of the truck is given using the principle of conservation of momentum. Calculate the speed of the joint engine and truck immediately after the collision. So before collision, we can write mass of truck is 0.3 kilogram and speed of truck is 0. Momentum of truck before collision is 0. Momentum of engine before collision is 0.16. We have calculated here. Total momentum before collision is 0.16 kilogram meter per second. Now after collision, the situation is mass of joint truck and engine is 0.5 plus 0.3, it is 0.8 kilogram. Let's take joint speed is v. So total momentum after collision will be mass multiplied by velocity speed. 0.8 multiplied by v. So we know from the principle of conservation of momentum that total momentum before collision should be equal to total momentum after collision. So 0.16 is equal to 0.8 v, and v is equal to 0.16 divided by 0.8, which is 0.2 meter per second in this case. Thank you very much for watching this video. Please write your feedback in the comment section. Thank you very much.